That the engine simulator and everything is, in function and stuff like that. Now I'm going to take you quickly through this piggyback system feature. Then I'm going to explain to you how a piggyback system works, and at the same time I'll be showing you around like how to tune a piggyback thing. So I have to connect first. Okay, can I do it? Well, yeah, I can do it, thankfully. Right, so this is the connect button. Doesn't even need an explanation. Connect, disconnect, and whatever you have. So you have settings here. In the settings, I have a unique feature which is the auto detect sensor, and so far I've tried it on 3 different map sensors and it detects it for you. The way it does is that it actually figures out the ambient pressure, and then since all the map sensors are linear, then it applies that formula based on so it gets the thing. So how a map sensor works is that a map sensor, when they say it's a 2-bar map sensor, it outputs 5 volts at 2 bar, and when it's giving 0 volts, that means it's in its least position at that period of time, which could be -1 bar or whatever. So anything in between is the amount of pressure in between. So that's how the ECU knows what's currently the pressure inside the intake manifold. Based on that pressure, the ECU is now able to understand, or approximately understand, that what's the amount of oxygen coming in the engine, so that in turn it can calculate the fuel, right? So let me take this opportunity because a lot of people won't be knowing this, that the engine works on 2 things, or any kind of combustion needs 2 things. You need oxygen, and then you need something to turn that thing into fire, right? So engine specifically works on gasoline, petrol, and the oxygen. So the oxygen is not controlled by the engine. The engine not controlled by the engine management system. It is mechanically consumed by the engine based on what kind of let's not get into that. So the engine management's job is to compensate, to provide a proportionate amount of fuel to match the thing, because there's a law which they call the lambda stuff, that it's at what do you, the stoichiometric or whatever thing they call it, that's supposed to be like 14.7 oxygen needs 1 fuel, some kind of a thing. So the engine management system can do that by injecting, because it can control the injectors. It can inject that much amount of fuel, and so on and so forth. So basically, how would it determine that how much fuel has to be injected? Is through the map sensor, right? So piggyback system allows you to manipulate that map sensor data, which is going into the engine management system, making it think that the amount of oxygen is more or less, causing it to inject more or less fuel than what it should have done in it would have done in a regular scenario, right? Okay, so besides this auto detect sensor, you have this quick toggling between the units. Some people prefer PSI, the American based people, and bar is more of me kind of a thing, and but while tuning KPA, I find it's best, because you have bigger numbers, so you have more resolution that way, and it's all the same anyway. So it happens instantly. Anything you do, everything in this piggyback system happens instantly. You don't have to go save and wait for and restart Windows and restart all that to make it come into effect. Yeah, no, it happens right then and there, and it's not gonna ask you, do you want to burn it to your, obviously you want to burn it to your thing, because that's why you're not playing, you want to burn it. Some I don't know, let's not get in. Then you have your rev limiter. Now it's set at 5. Let me set it at 8,000, right? And I hit this generate table labels, so you see it automatically interpolated from, it generated those tables, because you don't want to sometimes go and do it, and you want the system to make choose the best thing for you. So this is what it does. It also applies to this. So if you played with your min max of your map sensor, then it's going to generate also this for you when you hit this button, right? And okay, so that's your settings. Then you have clear log, to clear this thing, and it starts all the way from 0. And then you can save this log and then use my other log viewer software. You can also use the mega log viewer, which is also good enough software, to assess or to examine or to study or analyze or do whatever you want to do with what your data is. And remember that this piggyback system does not actually tell you that do you want to record or hit that record button, and so, because to me data is very important, so it should be recording even without me asking it to do so, right? So soon as you connect, it's recording, right? But now do you choose to save it or no? That's something depends on. And you want to start, like you want to discard the history, you can just hit the clear log and it's going to discard. And then this live mode is actually now showing you live data, but when you hit that live mode, it's going to toggle onto the unlive data, which is your log data, and it will allow you to assess it right then and there. We will get into this once we have some data, which we can play with, and hopefully if I don't forget. And then this is your table, this is your grid where the whole game happens. This is your important stuff. So this is where you will specify the amount of correction at a given RPM and at a given load. How much do you want to increase or decrease? We'll see it right in a minute. And this is open tune. You hit this open tune, or all these have keyboard shortcuts. So the highlighted alphabet, for example S in this case, is the shortcut for that, and then it will bring you this, and you select your tune and it's going to load that tune. And similarly you can save the tune and increase and decrease, increases and decreases this number, like that, or you also can hit A and S and do that. And this is your calc bar. So for example, I can say 12 into, and it will multiply, or was it into 12, 12 x, what was it? Yeah, sorry, 12 divided by, I forgot how was this. I'm gonna look into that later on. I don't have time for it right now. Or sorry, into 1.2. Sorry, 1.2 into. And I don't know. I forgot how this thing was working. Anyway, so but what I generally use is 12 plus, or 16 minus. It's gonna bring it minus there. Or if you just hit minus 18. It's gonna take you minus 18 and stuff like that. And so yeah, so this table has a lot of things that you can do with, and now let's say I'm gonna show you a very important feature, which is linearize, which actually linearizes the cell or smoothens out the cell for you. So I'll give you a very extreme example in this case so you can see the blend, and it's very beautiful to my eyes. So yeah, hitting L is going to linearize the thing, right? So I selected the whole range. You can select by Control A, and then I hit L and it linearized it for me. Right, now let me zero it out again, and let's say I have this minus 100 again, and this 100, and this 100 again, and this minus 100, and I select the whole cell, but I say Shift plus L, then it's only going to linearize it horizontally. Then I hit Control plus L, it's going to do it vertically, right? So you also have that feature. I'm gonna be adding some buttons here, to make. Also I have undo, so if I go back, undo and stuff. So I'm going to add those buttons also. And remember that all these features, everything here is not from any of these standard libraries. I've designed and coded every single thing. You see this animation on the thing, on the selection and everything is coded, and I've made it. I didn't want to pick up anything off the shelf. I wanted to customize everything, so I have it there. So I have full control, and I can make it to look the way I wanted it to look, so anyway, so let's get into the tuning part now, and I'll show you how things work, right? So let me go back to that extreme again, not minus one, yeah, minus 100, sorry, minus 100. Select the whole thing, linearize it. Okay, so now you see it's minus 20, and the sensor out is reading minus 20, whereas the sensor in is 45, right? So let's say if the piggyback system was not there, was not connected to your stock ECU, your stock ECU would have been seeing 45 kPa, and it would have been injecting the amount of fuel which it generally injects for 45 kPa. But now, since the piggyback system is there, it's fooling the ECU into believing or tricking it to see 13 kPa only, so it's going to reduce the fuel, right? So let's say you have bigger injectors and stuff like that, and it's flooding the engine at idling and stuff like that. So you can use some numbers and look at the wideband as a feedback and adjust accordingly, right? I'm not gonna get into how to know what fuel you need 14.7 at idling, so you want to increase or decrease this number, and the piggyback is going to increase or decrease this sensor in value and output the corrected value to the engine management system, and the engine management system is going to give you back on your lambda what you. So it's chasing the tail kind of a process. You increase, and then you see how closer have you gotten. You have to do it in steps, mini steps, and get to where you want it to go, right? Okay, so now I will show you, I will move this around and show you that as we move around, right? See, I was in minus 8 and it was reducing a good amount of, you can see that it was reducing something like minus 8, right? But when I move on to 4, right, it's barely increased anything. And why is that? It's because a lot of tuners don't understand is that this specific cell right now is not the only cell which is responsible for this position, for this map and this RPM. Because you see, this cell says 5000 RPM and 48 kPa, right? Whereas you are 45 kPa, not exactly that, and you are 200 RPM less than 5000. So it is not going to seek entirely from this cell. It's going to be looking even at the neighboring cells. So this is the range where it will be actually looking to get the correction value from, the correction amount from, and then it will be doing. A lot of tuners don't know that, so they just see that the highlighted cell is this one, so they just they modify that, and does not really make that big of a difference, right? So in this piggyback system, I have also introduced another unique feature, which is the extended marker mode. So I'll show you quickly. You hit X and this is what you get. See, extended now actually selects all the 4 cells which are actually in control or are in authority of correcting that position, right? So now if you want to see, I select the, there's another feature. Let's say your selection was here right now, right? Okay, and you hit spacebar and it's going to follow your marker, right? So it makes tuning easy. Now I hit 0, I zeroed the thing out, and you can see the sensor out has become sensor in, right? Yeah. So now it has worked. But imagine if it was back where it was, and if it was not in extended mode, and I zeroed this thing out, right? But there is still, okay, it's coming closer. Okay, it wanted to humiliate me in front of everybody, so yeah, be it that way. But I'm gonna play with the RPM a little bit to show you exactly what. Okay, now see, it's still in that cell, but look at the differences. There's a difference of 10 kPa, right? Because that cell alone is not responsible. So now I quickly hit X, and now it's this range. So I select the whole range and I zero it out, and now you will see that it will come back to 0. So I hope you're understanding what I mean to say, right? So that's all. That's your tuning, right? This is how you'll be correcting values. Now let me go around. Let me increase the map, and you will see that as this comes into this area where it's from -4 to -25, it's going to be bringing it to this position. Right now I decrease the RPM, and yeah, right, the correction will be applying. Now if I go up, you see it went into plus, so the sensor out has now increased, whereas the actual value is 30 kPa only. If I go down, it's the opposite. The actual sensor kPa is 120, and the corrected value is only 28, or something like that. So that's what you use Piggyback system for, right? And yeah, when you hold down the space bar, see how it follows? So it makes tuning easy. It's going to go there, and then you quickly zero, and it follows, and I zero it, or I increase the thing or decrease or whatever, right? So that's how so that's more or less how this thing works. And I'll show you quickly now how Piggyback. I'm going to give you a quick generic tip on tuning it works on almost any engine. What you do is, when you have your Piggyback installed, you have everything 0 if it's stock injectors and everything, right? What you do is, let's say your RPM, your rev limit is 8,000. You come and select from 6,000 to 8,000, and you simply go like -5, right? This is going to give you a quite a significant amount of horsepower, increase. How will it do that? Okay, let me try to explain it to you. Generally, the engine management systems, even though they know precisely how much fuel is required at a specific thing to give you the optimum performance, optimum fuel efficiency, optimum everything, they still have a contingency. It's a provision for some dumb fools who like to step on it 24/7, because they don't want, they give you a 3-year warranty period. They don't want you to come in those 3 years with a broken engine, because you've been slamming it like crazy, right? So they want to give enough room for any dumb fool that, be it a national day or be it whatever, he can step on it as much as he likes, but there is always going to be extra safety, because the different conditions, so they have to take all that thing into consideration. But that's why we can always go on the edge and fine-tune it to make it optimum. And since it's pig rich, we can lean it out. You can go even up to -10 depending on and I will show it to you when I tune the BM vet, that this is going to quickly make get you a good gain. It's going to increase your timing, because your map originally, let's say, okay, let me go here, okay, and the map is originally 85 kPa, right, and it has reduced it by 5 kPa. If you see that it's only a minute thing, not a big difference, then you can also go and minus it 10. So now you can see that 85 became 72, so you have 13 kPa was reduced. That's 0.12 bar, something like that, right? So let's say it's good enough. It's like almost, how much is that? Like 2 to 3 psi or 4 psi difference. So that's going to, oh no, not 4 psi. It's actually like almost like 1 bar. Yeah. Anyway, I'm getting confused myself now. So yeah, so you're gonna see that since the pressure is decreased, the ignition timing is going to increase, and the fuel is going to be slightly leaner. So lean is power, and increased ignition timing is also power. So therefore you'll have a good percentage of power hike in your system. So that's more or less, and this video has gotten slightly longer than, yeah, it's a 20-minute video. So I hope you enjoy, and stay tuned for the real world thing when I try it out on BM.